Anytime you're working with half-life, you should be considering the exponential relationship formula. Looks like this. Okay, in each piece, f of t means how much is left over after a certain amount of time. K stands for the starting amount of whatever you have. A is like the exponential rate, and t is the amount of time that's elapsed for all this stuff to happen. So we can go through and plug in the information we're given. Actually, the first thing you should always do with a half-life problem is find out what A is. And you get that rate from the half-life information. We're told that the half-life of an isotope is 5.2 years. So that's what it looks like when I plug that information in. If you start with 5 grams, half of it should be left over after 5.2 years. Now we have an equation to solve because we've got one variable. So your first goal should be to divide both sides by 5. You get that 1/2 equals a to the 5.2 power. And then your next goal should be to get a by itself. So you got to raise both sides to the power of 1 out of 5.2. Raise this side to the 1 out of 5.2 power. That's because if you raise a power to a power, they multiply. So 5.2 times 1 out of 5.2, that cancels, and that gives us just a. But we had to do the same to the other side to keep the equation balanced. So we need a calculator here. 0.5 to the 1 out of 5.2 power. So that's what I got in my calculator for A. So now that we have A, let's go back and see if we can answer their question. They're asking for how many years would it take for a 5-gram sample of the isotope to decay and have only 1.4 grams of it remain. So let's plug all that in. They want 1.4 left over, so I put that in for f of t. And our starting amount's 5 grams. The exponential rate we just found. But the question that they're asking is how long. So t is our variable. We don't know how long. So there, we've got a variable in an exponent position. That means we're going to need a logarithm to solve this problem. But your first step should be to get the exponent piece by itself. So you got to get rid of that times 5. Naturally, to undo times 5, you divide 5 from both sides. So that's what it looks like after we divide 5 from both sides. And now we can take a log of both sides. And again, if you haven't worked with logarithms too much, just remember it doesn't matter what type of log you take. And the reason we do it is because if you take a log of both sides, the exponent inside a logarithm can come down and multiply. So that becomes t natural log 0.8752. Yeah, squeeze that 2 right in there. Yeah, and so now we can solve for t. If it's not an exponent, we can get t by itself. Because look, this is just a number. It's a messy one, but 0.8752 is a number in your calculator. So to solve this equation for t, to get t by itself, just divide natural log 0.8752 in your calculator from both sides. And so what you're going to get is that t equals natural log of 0.28 divided by natural log of 0.8752. Whatever that is goes here. And there it is. 9.55 is how many years it'll take for those conditions to be satisfied.